So we're about to do copying from one register to another. So I'm going to grab this example and I'm going to make another test because I like tests. Let's just copy this whole thing. Oops. So instead of from location 41, we want
from location.
Oh yeah. How did I do this? From location, we haven't done it yet.
Right.
Okay, this, so we're going to do from location register.
Yeah.
And we're copying from
A
to register C. And this should fail saying that, like, okay, because we don't have this type yet.
Yep.
So we're going to go add. Like, this looks a little silly. Register.
Yeah. But
like, that's what it is, I guess.
Yeah.
All right. So our register name is not an invalid digit because we're just trying to parse it as a number.
Now, did you notice the magic there?
Which magic?
Like,
where?
You just added it and it's automatically trying to parse it. Like, it's not magic. That's the wrong word. But like, you didn't have to go and change it. Like, because it's just calling the existing parsing function.
What else would it do?
I'm just saying, like, because we called .parse and it's generic and all that stuff.
Okay.
Doesn't matter.
Okay. Jake just lost me.
Oh, there we go.
But like, it's not working because we're only trying to parse.
Right. I'm saying all the plumbing occurred because we're using existing things.
All right.
So I think this should basically just be match on S if it's.
Should we match on parse? Because if it parses, then it's an integer, right? We're going to have to use turbofish, though.
No, actually you wouldn't, but try this. So I would do...
How are we not going to... Okay, here's what I'm going to do. I'm going to do this.
Okay.
So if this is okay, then we know we have this one.
Yep.
And if it's an error, then actually we could probably just do underscore, but whatever. We actually want to, then we want to try and parse it as a register.
Right, which could fail. So then you want to try calling, how do I want to say this? It can't be okay because the interior one might fail.
Can we just
I guess if you want to, you could do okay of from location register dot parse question mark. It's a little weird, but I think. Yes, parse mark, and go ahead and put the okay that I was confused about. I think this will actually compile. I don't know if I think it's obvious code, but
okay, it passed, compiled and passed. So what would you do instead?
Do you want to commit before we refactor?
Sure. All right.
So in this case, I would probably want, so like I see that we have okay, which that's a map. And then I see error going to an error case or to like a second case, and that's and then, or sorry, not and then, that's or else. So I would probably want to do this as s.parse dot map, and this will be I, and then from location : integer. Actually, you can take out the pipe I and just do from location integer. That's a function. And then or else from location. Let's say that.
We want to like do this again, right?
Yeah.
But there's nothing handling if this errors. Does that matter?
So the parse will fail and generate a result. Then it'll have an error, and then
that'll get returned from here because it.
Right, and then the or else will keep it as the error.
Okay.
And then I'm probably wrong in the compiler rule. I'm going to parse for parse int error. Okay, so that or else. Let's look at the docs for result. So I might. So calls. So if the result was an error, it calls it with the error. Oh, and we don't care about the error. We just, if it was an error, we want to go to something else.
So do we just want or?
We don't want the pipe s in the closure for or else. We don't care about that value. We're going to make the pipe s an underscore because we want the input string. We want to try parsing a second thing. But that's probably how I would write it. Mostly because like there's some map stuff. I don't know if it's actually easier to understand, but I do like using maps and like the chaining of or else and stuff like that. Also, this just avoids any of the question mark or try or anything like that.
I mean, it doesn't avoid it because it's kind of like built in here, but you don't
avoids
type it out and read it. Okay. So I think that's all the copy.
Integer or the value of a register, yeah.
Except we're not, so we're parsing. We're just parsing.
Just
right now.
parsing,
We're not
yep.
interpreting. Okay, so should we parse inc?
Yeah.
And I'm going to make another test. And we want this to be increment, and we want this to be a register.
Okay. And change your test name from parse copy.
And we don't have that type, so we're going to go to the instruction. We're going to add increment register. And we're not.
We haven't. That's
it's trying to parse it as a copy.
Well,
because we haven't implemented that, right? Oh.
It's line 29 here.
Oh, okay. It's hitting our unimplemented.
Yeah.
Okay, good. That's good. 29 on unimplemented. So here we're going to match some inc.
Yep. So instruction increment of parts.next okay or no register First question mark. Yes.
Decrement.
Yep.
Should be fairly straightforward. Okay. And what's left? Jump not 0. Jins.
And this is going to have a register and an offset part of jump.
We
I don't know. In this case, I'd be okay with it just being a number.
Okay.
Which it needs to be a signed number. So we'll do our I-32 here.
Okay. Is this what we want this to look like? Oh wait, we want this to be 2. I was trying to write it the type. This is register.
And
Okay, it's going to hit the unimplemented.
Yeah.
So here we want, it's going to be more like copy than the other two. This is going to be no register. It's going to be no offset. And
yeah. While we're in this method, let's change that underscore to an error.
Okay.
Because now we think that we're
we think we're done.
Yeah.
Oops. Okay, because we have
right. So we might actually want a some other here.
okay. But then we also have to have none.
Yeah.
Would you do this here?
You
no,
can't. Yeah. I would just do a second error case where it's like there was no instruction.
Into
No. None.
No. No, you told me.
I swear that we did this earlier. Oh, I always forget that. You can't do it just as a string, but everywhere else we were doing it with the question mark operator, which automatically does the error conversion. Yeah.
Okay. 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 So
now we're parsing everything. So now we have to do the hard part.
The interpreting.
Yeah. It's actually not that bad, but.
Yeah. So how do you want to go about this?
Well, we could do something very similar. So the idea with like our integration test here is that we've got a bunch of things. We're going to iterate over each line. We're going to parse it as an instruction. We're going to take that instruction. We're going to shove it into some struct that represents our machine. And
Not to store it though, to
no, to like,
interpret it,
yeah,
to run it.
it would be like a dot process or a dot run or a dot interpret method on that struct, and we'll hand it an instruction. That's one way of doing it. The other is we could actually collect it into a vector, and then like that's our program. A vector of instructions is our program, which I think we need because of the jumps, because we can go forwards and backwards.
Yeah. Okay. So we could change this test to just check that we parse this whole thing into the vector, right? But do we care about that intermediate result or not really?
It depends on how tricky that bit of code is, I think.
Okay.
How, like the parsing into a vec thing, which I mean, I think is basically lines dot map trim,
Yeah.
parse collect. So we could do something very similar, which is now that we know that we can parse each of these instructions, we could just have the hard-coded instruction, which is basically from our above tests, and push them into a machine, or create the program and like step it through. We could do lots of things like that. So we could.
So like have tests for just this instruction and this instruction and this instruction. And
if we wanted to, yeah.
Okay. What do we want to do?
I don't know. I think I would probably be most tempted to go ahead and just do it all, like write the implementation of everything, and then see if the test pass. And then when the test doesn't pass, write focused tests for the hard things.
All right, let's cowboy this up. That seems like a huge step to me, but
Well, what's a smaller step? Because I'm open to it.
Is like one at a time.
Let's do it.
Like, let's make a new machine, then let's feed it just this instruction, and then but then like we'd have to be, so I'm imagining this puzzle thing is just going to return, all we want to know from the outside is what's in register A.
Yep.
But there's a lot of stuff potentially going on in the inside of the machine that has to do with the other registers that we might care about. So it's not, if our public interface is only the value of register A, then we'd have to write ways to peek inside the implementation to test that, which isn't horrible either, but
I mean, I see there being a register struct, or not register, like a machine struct.
Mm-hmm.
That,
and we can call .a on it.
Yeah.
Okay.
And like puzzle, because that's all we care about, like it might inside of it create the machine, feed in the instructions, do the parsing, and then return just .a from the end.
Okay. Do we want to hard code the .a? Well, we'll get into that. Okay, so here's what I want to do. I want to test that it's a new machine.
Okay.
Executes we want to do an integer, and let's do 5 for fun into register A.
Okay. And
then I want to assert so if we do that, then we're hard coding a method for each register when we already have this nice enum of possible registers. So I'm kind of thinking something like this instead.
Okay.
What do you think about that?
Sounds good. Biggest thing I see is that execute is taking a single instruction, and we know it's going to want to take multiple.
Okay.
So I might just do like, I just pass it a slice. Doesn't need to be like. Okay.
I don't like this.
No, it's all wrong.
I hate this too.
Oh, it's terrible.
I think this is pretty.
That's fine. All right, we're gonna have all sorts of errors.
Okay, let's make a machine. I'm going to do it closer to the test because we're moving back and forth a lot here. Okay. I don't know what it's going to have yet.
Yep. That's fine.
But I made a new method.
I'm very happy it was actually that wasn't allowed in Rust 1.0,
Yeah.
an empty struct like that. But I find myself doing exactly what you're doing, which is like, I don't know, but I know there's something in there. Okay. Execute.
And this takes a slice of
Instructions. Issue a
that's-
name.
and we need a value of
Yep.
and this is going to return 932.
932.
And this is going to complain about it. Okay.
Didn't
So,
work.
what?
Didn't work.
Yay! Okay.
So let's start with the easy thing. For instruction and instructions, which I know we're going to change, and it will not be actually what we want, but match instruction. Implemented, yeah.
Okay.
All right.
So what are we going to do for copy? We have,
So
this can be a value or a register.
right. I think if you look back at the problem statement, it says that the machine starts in a certain state.
Ah, yeah.
I
They
think it's-
start at 0.
Yeah.
So we need to start all our registers.
Yep.
At 0.
Yep.
So, and that's what the struct is going to hold on to.
To start with.
So because of the way that I've
Mhm.
defined value of, I think we want this to be a hash map of register to I32. What do you think about that?
I would probably make it an array, and then in the value of, I would just match and return 0 for A and 1 for B and 2 for, and then index into the array.
And why would you do that?
Hash map feels heavy to me. Like it's a small fixed set. It's 4 things. We know it's not an unbounded set of keys.
What if day 2 makes a whole bunch more registers?
Then I would change it to a hash map at that point in time.
Okay. So you just want
Registers.
not even register. You just want I32 for,
Oh, right.
right?
Yep.
And
Semicolon.
semicolon. Okay, so I have to initialize these. And then do we want to finish the copy, or do you want to implement value of what you were just saying?
Value of is easy, so we can do that. So I basically say like, yeah, match on register.
Would you do your fun used register?
I might. And then A0. Yeah. I have a feeling we'll do something later that we'll see if you agree with or not. Okay, and then self register as index.
Oh, we haven't finished implementing this yet. Okay.
It should still compile right now because that doesn't have any returns.
Yeah, I guess.
Expected preference.
I would do this here.
You didn't make anything copy, right?
No.
So you can change match star instruction instead. And then we have to change from into to graph. Okay.
All right. So,
so this is interesting because you could actually, inside of instruction copy, instead of just from, you could actually say, you could add the register or integer. So you could say instruction copy, copy from location. I mean.
let's do that. That'll be fun. Okay. So this is going to be
From location, : integer. Then, yeah. Then
it's going to have to be ref I, right?
No, because that'll be an
that's
integer.
copy.
Yeah.
Okay. I hate this. Okay. So in this case, we need like a set function.
I mean,
go
I would
with
probably
this.
just start with it in line there.
But then it's duplicated here.
And that's why I think, I'm not sure if you're gonna like this or not, but
You're gonna make register into from integer for register?
Nah, but I would move that match essentially, the use register to the end of the match into a method on register. Why don't you like that?
Because it's coupling the implementation of the machine to the values of the names of the registers.
Yep.
What can I just have a hash map?
If you want to. I mean, it's not like this needs to be efficient.
Yeah.
It's not like people use Rust for efficient code.
What if we make a method on machine that's register index?
You could do that too, yeah.
I feel slightly better about that.
Okay.
It's a little silly to be a
yeah, it doesn't need to be.
So I'm going to move all of this.
You want to use too. And then change value of to be, yeah.
Okay. This is going to be 2. This is going to be I. And then we're done with from integer, right?
Probably. I don't think it'll compile yet, but structure is right. I would just make these things copy.
Yeah.
Like basically everything can be copied at this point. Copy clone.
Meh.
And then we got to
You
get
get
rid
the
of the
ref.
ref. Yep. And if you want, you can now put the ampersand on the for instruction.
Yay, I passed.
All right.
Okay. So now that we can put a value into a register,
Mhm.
I kind of want to test copying from one register to another.
Do it.
We're going to put 5 in A, and then we're going to put A in B. And then we're going to check that B is 5. And I messed something up.
I think I'm missing comma.
Yeah, missed this. And I should put a comma.
Yeah.
And then I should do it up here too. So paste again. Okay. All right. So B is 0, and we want it to be 5. So now we have to implement copying from register.
Yeah.
We've got the start of that up here. We don't need the refs anymore.
Right.
But we know this is a register.
Yeah, you should go ahead and do from location : colon register.
We don't need the.
Yeah.
So we need 2 indexes.
Yeah.
We need.
I would probably shadow the variable. I don't think we have to. I'm just stating that I would. Doesn't matter.
But you didn't bring this up here. Would
No.
you shadow here too?
Probably.
I
But-
kind of like it the way we have it
Yeah.
for now. And what we want to do here is
Self-registers. Oh, index 2.
yeah. There you go, just proving me wrong right away. Okay.
Passed.
So increase can be with one register.
So we'll put a value in.
We don't have to. We could start from 0.
Oh, that's right. Good point.
Um,
So instruction increase. Register C.
just to test all our.
The A is boring. Okay.
I like you, A. I don't think you're boring. Ew. Why?
It's not increase, it's increment.
Ugh.
And change the test name too. Okay. Yeah, it's
Sitting around implemented. So
instruction. Increment. Okay. That index, yeah.
all right, and similar thing for decrement.
Yep. Is actually very good because now we can make sure that we actually do have negative numbers. Didn't accidentally.
Underflow.
Nope.
We didn't. I'm just completing your sentence for you. We
Oh,
didn't accidentally
didn't-
underflow.
yeah.
Or use the wrong type somewhere. I forgot a comma here.
Blah, 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 minus 1.
Minus 1.
Now we're going to do the thing that makes us change our code. But that's okay.
Okay, so we want to, I haven't even like wrapped my brain around the jump yet.
So jumping in like normal assembly is tricky. And I feel like this is a slightly different tricky. So it says when you jump,
it's only if X is not 0.
right. So it looks at the value in the register X. And then if it's not 0, then it changes the program counter. And the thing is, it says an offset of -1 would continue at the previous instruction. So, and this is why it's good that they do have the examples. So they say here that it's going to jump by 2, which means that the next value that it, or the next instruction that it would execute is the one after dec A.
Which is none.
Which is none, and when you run out of instructions, you stop running the program.
Okay.
What I wish they had was what an example of -1 would actually be. Because I'm pretty sure that they're saying if that was
I think
-1,
it would start at the dec A. So we need to not only keep the instructions we're going to run, we need to keep the instructions we need to like shove them into another array or something, another back.
Well, we can just keep which index we're on, which instruction we're running.
Then we're not using iterators. We're just
we can't use an iterator. We're gonna like skip all around.
Okay.
Yeah.
Okay, fine.
Which is why we're taking a slice.
Okay.
We just have to get rid of the for loop.
But we could do an easy thing first, which is that we do nothing if X is 0.
That's true, except we already do nothing. Well, I guess we do unimplemented, so you could change it to be empty parentheses instead of unimplemented, and then we'd pass that test.
I mostly just want that test so that when we have the other case, we don't accidentally do something.
Okay. So it's a test that we'll probably pass to start with.
Yeah.
And then
we're going to make sure we don't make it fail.
Okay.
So we have to write it in a way.
So if we, non-zero.
So if we say this, then we'll get an infinite loop. I'm not sure if that's a good test case. What if we do 2, and then we have like increment A, and then we check the value A. Increment for fun, get some variety here. So A should be 0 if we haven't done anything on the jump, because this 2 will jump over this and stop.
Sounds right to me.
I think it's, well, it's just going to hit the unimplemented right now, so it's going to fail. Yeah. So if we implement this.
Okay, yeah, I see where you're going. It may not be like a null test. It might actually show something interesting.
So if we do nothing right now, it's going to fail.
Get rid of the underscore, because that should be the next match arm. That should be the last. It should fail. Yeah.
because it's not doing nothing. It's
Yeah.
it's not doing the wait. No, I'm confused now. Because it should not be. I think we did this backwards.
We did jump 0, didn't we? Is what we were thinking it was.
Yeah.
Okay. So jump if non-zero.
So this should do nothing.
Because your test name and your test body aren't matching.
Yeah.
It says when 0. Okay.
This is the way it's supposed to be, right? Only if x is not 0. So we want
this is the test that I wanted to write.
this. Okay. This is not the test I want to write.
Yeah.
So I'm going to get rid of the d.
Yeah.
Because d should be 0.
And so in this case, it should be a. Or sorry, a should be incremented.
Yeah.
So we want assert that it is 1.
Okay. So now,
This test should pass.
because we're not doing anything, we're not doing the jump, so we are going to increment.
I'm glad that we had talked out what we wanted to do and knew that it
And
wasn't.
realized that it was backwards.
Yeah, when's the last time you committed?
I don't know. Why haven't you haven't been prompting me to commit?
I only commit.
Here.
I only commit when I'm done and it's beautiful code.
So
now we do the opposite. I wonder what that code should look like.
I shouldn't have deleted the code. I'm gonna copy it again from up here. So here D is not. Wait, did I just changed the wrong test? D is -1. So this is non-zero. So
Yep.
it's going to do 2, and A should be 0.
Yep.
Now this should fail.
Yep. All right.
So I've got to change everything.
Everything. We'll make small changes, make it not so bad. Okay. So basically, instead of for instructions, we want a program counter. And it's going to start at 0, yeah. And then we're going to say, while let some instruction equals instructions dot get program counter. Let's see if our test still pass. I don't think you, well, yeah, I guess you do need that because it's a get. So that's good. We just forgot a step. So
I forgot to increment
Yep.
program counter.
So we'll start by just doing that at the end of the while let. I'm pretty sure that in our like mess of like warnings, it was like, hey, you made this mutable and it doesn't need to be. Yeah, right there at the end. But we have all these other things.
Okay. So we're still not doing anything for the jump.
So we have not changed anything. We've just made it so that we can change things.
Yeah.
Okay. And this is why I don't like this implementation of jump. Because see how we put program counter +1 at the end?
Mm-hmm.
Like that's actually very normal. And that's how like hardware does it too. And so normally, if you were to do a jump of 0, it would actually mean like continue doing the next thing. And a jump of -1 would actually mean repeat the jump command again. But in this code, it's actually
I just blew your mind, didn't I?
See, hardware doesn't work like that, so that's why I don't
But
think
we
that
don't
like
have
that.
hardware.
Okay.
This is all software.
This variable can be inside the whilelet because it doesn't need to live longer.
Okay.
And then basically inside the jump non-zero block.
So this is, I forget
Register.
already, register and offset. So if we need to get
The index.
if this is not 0, then jump equals offset.
So the
Which
problem
one
here
is
is, so program
Oh.
counter is a U size because it's indexing into a array. So it can never be negative. So,
So our offsets, we should parse them as,
well, no, because offsets have to be negative. We have to be able to jump backwards. So we have to do things here. It's annoying.
And we have to make sure we don't go outside of our instructions.
Well, we do that already. That's what the get on the set of instructions was for.
Well, that's after. Like, what happens if we say jump negative 100?
So
Should
negative
we-
negative is the problem. I was saying if we go too far, too high. Too high is handled by the .get.
But is that where we want to handle it? Like that'll just, yeah, I guess that just
end
means
the
end
program.
the program.
Yeah.
It doesn't matter how far you've jumped
Right.
past the end. But yeah, negative, I feel like we should handle this here.
And so this is a thing. In hardware, such a thing would probably actually jump you to a very high number because it would just do unsigned arithmetic.
Which is also past the end of the array.
Right. And would also stop the
Usually.
program for
Yeah.
us.
But what if we get a really long program? Like really long. I mean, I don't know how.
Right. Or if you had a number that you subtracted a big enough negative offset
Yeah.
that you wrap back around to a small positive number. So the thing is, like, it is tricky. So the other thing we could say is we could have the equivalent of a machine check exception, which is we could basically just kill the program in our case. So we could take offset, convert it to an I32, for example, add the two numbers, and then if it's less than 0, panic.
But offset's already an I32.
Right. Sorry, I meant convert program counter to an I32.
Okay.
Do the addition. And then if it's less than 0, fail. If it's greater than 0, convert it to a U size.
So here's the thing. Maybe that wouldn't work. I wanted to move this above here so that we always do it, but then we can adjust it in here. But that we'd have to like adjust it back out the one because it's supposed to be relative to the current instruction, not the next instruction. Like, because we basically need to do this math in here to check it. Or should we just check it out here?
You can check it out there, yeah.
Okay, let's do that instead because I don't want to.
So then just jump equals offset.
Okay.
Okay. And then, so basically, so what were we saying? So, did 1 plus jump is less than 0. Okay.
you feel about that?
It's all right. And then you need to no,
Why not?
because jump could still be -3. Okay, actually, no, sorry.
But
This
it's after.
this check is wrong because jump could be -6. That's fine as long as program
plus
counter
program
is 7.
counter.
And then this will be a problem because program counter and jump are different types. Jump is I and program counter is a.
Will this plus equals work anymore?
Um,
Or do we have to do like,
So probably what I would do is do this first thing that you've got here, this if program counter as blah, 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 and store that into a variable.
oops,
Yeah.
too much.
Yeah. That'll just be a sign.
Okay. But our samples still, we haven't implemented puzzle yet.
Yeah.
Okay. We actually want to do
Input lines dot map line dot trim dot parse because well parse, and this is going to be dot collect. And we're going to collect this into a some variable. I can't think of a good name. And this is going to be of type result of vec of underscore vec underscore comma underscore error type. Okay.
I don't care about it's,
And then and I want to do, I guess, since we're not able to return results or we don't have it currently returning a result. Do you wish this function to be able to fail?
not really, because then I'd have to change my main and I don't want to.
Okay, and throw dot accept, I guess, for instructions of the results. So we gotta.
Can I just no? Can't you said accept, but you mean expect.
Yes. Okay. And machine get value of stray.
Like this isn't gonna work. Oh, it worked. Okay.
Why didn't it work? We wrote
I
all
don't
those
know.
tests.
Okay. So
Unknown register 1.
what we forgot something. Is our copy backwards?
Let's go enhance our error reporting.
So we're getting okay, unknown register 1. Okay.
So here, and this is what Brian Anderson talks about with his error chain. He's like, we create these errors, but we don't necessarily do the cause very well on them. So anyway, so let's so where do we call register parse? So like look.
Well, I can't search for anything because it's all just into calls.
Let's all parse calls, but
so I think it's in the copy.
okay. I mean, we could of course be cheesy and print out each thing that we're trying to parse before we parse it and see what the last one is before it fails.
I think it's this one, but yeah, we can do what you just said.
You know, I saw that in the instructions, and I was like, this is a little ambiguous, and I didn't say anything, and I feel bad.
You don't feel bad. You regret not showing how smart you were.
What's the difference? This is too late. It's when parsing.
It's parsing. Where are we doing that?
Up, right there.
Okay. So
it's not just a register when you do J and Z. Yeah. Okay. Compile it. Does it tell us where theirs are? It's probably not the best name anymore, but
yeah.
okay. So
Gross.
131. So this is going to be something similar to what we did above, where we match, yeah. Location manager. Okay. I is not 0. All of our tests need to do that too.
Our test would have been simpler if I had known about this. Or just put 1 in here and 0. Okay.
And so
That sure looks like an infinite loop to me.
yeah, just in case you want to run it in release mode, I'm pretty sure that you're right. It's an infinite loop, but just in case it happens to be doing the world's slowest, like Fibonacci sequence or something crazy. Okay. I bet you're right. It's an infinite loop, and I bet it's because we're not doing the jump correctly. Because I think we're not jumping the right amount.
Spell that one. Display.
Yeah.
Ooh, boy. Okay.
Okay. So it is saying, well, B is non-zero.
So where does it start repeating?
Yeah,
right
see
in
here. So we're starting at instruction 4, and it says jump 5, and then we go to 10. This is what I was trying to say earlier. It's like we're not supposed to add 1 in the case of a jump. That 1 shouldn't happen then.
Ugh.
That's the thing is you wrote the code. So what, like the hack that you can do in this case is subtract 1 from the offset in the jump, essentially.
But is it always? Or is it only in timeline? Let's just.
Or if you wanted to, actually, you can change the jump. There's 2 places we need to set it. There's 2 cases for.
Oh, right. So looping.
So 0, 1, 2, 3, 4, and it does jump.
9.
Now it's at 9. Copy A to C. Then increment A, decrement B. Okay, so what should we have done here? So we copied 1 to A, 1 to B, 26 to D. If C is non-zero, which is not. If 1 is non-zero, which it is non-zero, so we jump forward 5. Now we're at 9. Then we copy E1 to C. Then we increment A to 1, from 1 to 2.
Mhm.
And decrement B should be from 1 to 0.
Mm-hmm.
Then if B is non-zero, which it is not.
And so -2, which we didn't do because the next one's 13. So that's fine. Right?
Seems right.
So then we copy C to B. And C is 1.
Yep.
So B is 1. D is 25. I kind of want to print out all the register state.
Do it.
Should I just debug the machine, or should I make something nicer?
I mean, I might just do dot registers.
Okay.
Wait,
So
can
we
we scroll
were.
to the very beginning again? Oh, okay, yeah. So the registers, there's a register before the instruction happens.
Yeah. This is just saying.
Yep.
We're executing this instruction. Should we print it out after again, or like?
I think
bring...
I would just change the order of the prints, and that'll probably be enough for me.
Okay. All right. So we were about up to
copy D to something.
Decrement D. That was around when I stopped being able to hold it in my head. So jump non-zero -6.
And we copy A to C, we increment A, increment B, Jump if non-zero B, it's not. So then we repeat the last two. So 12. Oh, no, it is 0, so we don't do anything. It keeps getting me. Copy. If you are going faster than I am, you can scroll.
I'm just looking at the repeating here.
Mhm.
So my current hypothesis is this 15 minus 6 to 9 that's wrong. I know that's what the math is, but I feel like that's off by 1.
Yeah, let's go read the docs again, because this is why I was hoping that they'd had an example of negative, but
An offset of -1 would continue at the previous instruction. So if we're at instruction 2 and we jump to -1, it should be 2 minus 1 is 1. So that should be right.
I
Okay.
think so.
So now I want to go back, and because the D is going down very slowly.
Mhm.
So I want to see if we're maybe just not waiting long enough. Wait, or changed. Or maybe it's just the digits. 21, 20. Yeah, just the alignment change. 20.
You sure? Because now we're doing increment, decrement, jump, increment, decrement, jump, increment, decrement, jump.
We stopped decrementing D. We're checking D and decrementing D at 14. Okay, so what happened in here?
So we did jump -6, right? So we're at 9. And we copied A to C. So 21 and 21. Then
Somewhere we're going.
oh, I see what happens. So see the B here, it's 8, 7, 6, 5, 4, 3, 2, 0. And then we have a jump non-zero on B.
Okay.
So now it doesn't jump, it falls through, and then it copies C to B, and decrements D, and then it goes off into. But the thing is, if it's incrementing A and decrementing B, it should eventually
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
and then it
And it goes
copies
to 21.
C to B.
Are we really just not waiting long enough?
Maybe. And then keeps going down, because then it goes up to 35. So I would say let's comment out our prints and run it in release mode.
How long do we wait? Like, what's the end game here? Let me look at the input again. Yeah, I can't tell what the end game is here. Because we're stuck in like 10, 11, 12. And then there's this outer loop here. We need D to be 0. It's 18, 17, 16, 15, 14, 13. Like, I want a sign that we got to a particular point.
Mm-hmm.
We waited until D was 8 and killed it that time.
So let's comment out the prints, because those make it slower. and run it in release mode and see. Those are the ones in the loop. Go run release. Throw time before that.
We still don't know. Ooh.
See? Colors are good.
But didn't we, oh, I guess we had the printing on when we ran it in release mode before.
Mhm.
Okay, let's see if we're right or not. Yay! Okay, commit. Okay.
See what they've got for part 2.
Notice it didn't start. Register C needs to be initialized. The position of the ignition key. Oh, is that all?
If you instead initialize register C to be 1, value is now left in A. Okay.
So that's easy.
Kel and I disagree on this because she changes her program from part 1 to part 2. I make it so that the program works for both parts concurrently. Nice.
Yay!
Alrighty.
That was one of the easier modifications. And we'll push this up to GitHub, push the tags up. And I hope whoever is watching this has enjoyed watching us code and mess up and cause infinite loops and eventually stare at the logs long enough that we could figure out how to fix it.
To not fix it.
Way long enough. We might try streaming again sometime. Bye.